Everyone, welcome to Baozi Training Leetcode solution. If you want the best software engineer mock interview experience in North America, feel free to check us out at baozitraining.org. We're here to help you. And also, I just realized we have these very cool, awesome videos. I'm not sure if you guys watched it.
Interview training. One day later, Michael's debrief session.
Pretty nice video. Anyways, so okay. So feel free to just remember to check us out or subscribe to our WeChat blog. So I'm trying my best nowadays to at least publish one video plus like one blog about Leetcode, and later on I will also publish more like a system architecture type of questions. So leave some comments if you have some kind of system architecture related questions that you are not sure of, and then you want to kind of like we can help you discuss and maybe write some blogs. Yeah, feel free to leave some comments under the YouTube video or under the blog. Either way is fine. So today we're going to talk about a kind of like old but interesting problem. It's a little bit hard as well. It's not that easy. Took me quite some time to think it through. So here's the problem. It's called wildcard matching. Card sounds like a British accent. Anyways, so you can see the number is 44. That means it's a very early question. So essentially what this question means is, given like a string S and also a pattern P, and then there's two unique characters, right? So one is a question mark, which can match one and only one single character. And then a star can match any sequence of characters, including empty sequences. Like it can, basically a star can map to an empty string. So now given this, so given S, given a P, so you're gonna basically return whether this is true or false, like whether they match or not match. So here's my thought process, right? So whenever you look at this question, so let's just say look at this like example 5, you have S and then you have P. So as long as if you don't see any stars, right? So you have 2 pointers and then you keep comparing, but now if you see a star, you'll be like, oh, okay, because it can means 0 to as many of the characters. So what naturally we can do is two ways, right? So let's say in this case, it's like, okay, if you mean 0 star, zeros. So basically what I will do is I'll start matching this CDCB with the rest of your string. So that's one recursion. Or if that returns true, we're good. Or what we do is this can map any strings, right? So a naive and very, very brute force solution is I will just start matching from, CB to this, and then also DCB to this. So essentially every single substring. So let me quickly show you what I mean by that. So spoiler alert, that is basically that would be TLE, time limit exceeded. So what I wrote is, okay, first do some kind of not necessary check. So now I will call is match helper. But this match helper, previously I did not add this. So it's essentially, okay, so if you already reached the end, they have to be exactly the same before you say it's a true. But then this is the interesting part. This is the brute force part. So for this brute force part, what I did was, if you are a star, so what we can do is, we'll just recurse. So if you are a star, what we do is first we'll J plus 1. So that pretty much means in this case is, let's say if we're here, so that's like using the existing substring to match the ones without the star. So it's like DEF maps DEF. And if that's the case, so this comes later as the optimization part, is if you are already the last string or you're matched to the last part, so that means you're already cool, so you return to true. But that's not the point. The point is now I have to do a for loop for the rest of the part, which is I'm mapping from here, like the star can represent literally from like 1 to any characters in this case. So I'm doing like from EF I match your whole string, and then from F I match to your whole string. If you have substrings, I continue doing that. So essentially it's a for loop nested with a recursion call. The else part is easy. So if it's a character match, so I extract it into a separate function, which means they either the character equal to each other, or it's actually equals to a question mark, which matches to any string. So as long as they match, we just basically I plus 1 and then j plus 1, just like a happy case, and then just continue calling this recursion function. So what you will quickly realize, this is actually what's the time complexity I mapped here is actually exponential one. So assuming s is m, length is m, p length is n. So this is basically because you're looping through m, and then for each of the character, they have two chances whether they're in or they're not in the string, right? So that's basically 2 to the power of n. That's exponential. So I was basically trying to make it a little bit simpler. One case I can think of is I did not really pruning the recursion, but more like a heuristic. So if you have because when I submitted, it will tell me it's TLE, right? I'm like getting mad, why? And then the one case what you can do is if you have like multiple stars like this, you have 3 stars. I wrote a quick function like remove duplicate stars. So essentially this will trim it. Like if you have 2 star or multiple consecutive stars, it will just reduce to 1. Well, still no luck. That will still give you exponential time. That's just a simple heuristic. So that's for that part. This won't work. And then a natural part is essentially like a dynamic programming. So what we can do, it's kind of like this falls perfectly into dynamic programming because dynamic programming normally solves 2 types of problems. One is basically only asking a yes or no, true or false, without returning the detailed step. So if you're asking, okay, can it return the match? Then what are the match? What are the passes? Then you can basically not answering this because dynamic programming is more like a lookup, right? So like you keep a like either 1-dimensional or 2-dimensional arrays. It's just telling you the final result. And the dynamic programming DP is also very good for extreme values. For example, what is the max of this, minimum of this, best value, like best route, maximal sum, those kind of things. So I have posted actually several videos. If you go back to Baozi Training YouTube channel, you can see there's actually a perfect template for dynamic programming. So there are a few steps, right? So one, you initialize your array, you initialize your values, and then you have some kind of formula to populate all these values, and then the last step is you code it up. So here's the code. So it's actually very clean and very simple to understand. But what I'm gonna do is actually I'll give you one example how this dynamic programming came up, right? So let's say your string is S ACB and your your pattern is A star B. We know by just quickly look at it, this should return true because this star can basically be matched to a C, and then this should return true. But how does it work? So as you know, so if this is the length m, so this equals to 3, and then this n also equals to 3. So what we normally do is we give an extra room, right? So it's like because we need to populate the initial values. It's like these are the initial values I meant. Not this. Let's say those are the too dark. This, and also those are the initial values what I meant, right? So what you need to do is you want to give yourself like a buffer room to get the initial values, and then the yellow ones are actually the real truth table. But because of the formula, it always needs to look up a previous value, so that's why you want to give these initial values. Now the second step is how do we populate it? So if we look at the code, so what I did here is some check, and then you have your row and column, which in this case is m and n, and then what I said literally just meant what I just said literally just meant you allocate a 2-dimensional array with like row +1 and column +1, so that your lookup table is very easy. So we can always populate some values like this 0, 0 equals to true. So by looking at this, if you think about it, like this is the I part, and then this is the J part. So essentially, this is the S, this is the J, this is the P. Like P is more like a column, S is more like a rows. Okay, so this has to equal to true because if you map a empty string to map string empty string, they match. So perfectly true. And now what I did is I need to populate the values, right? So here what I populated is more like the columns, because only in J, which is like in column in J or P patterns, there can be some kind of weird characters like a question mark or star, right? So what I populated is more like like this dimensional. So the rule is, so if you see a star and then the previous value is also a star, like a true, that means you can actually map it to true. So let's say here you have to map it to false because it's not a star. So this is a star, but previous value is false, so you have to be false. However, if this is a star, so this can be a true, right? Because a star can literally map to anything. So this is a true, and then this will also becomes true. But that's not our example. So let's change it back. Okay. So we populate this, and then by default in Java, if I allocate an array, everything defaults to the default value. For Boolean is false, so all of this is false. So I did not explicitly initialize that. And now let's look up the formula. So this is basically the pattern. So we, it's not very easy to look. Okay, this is much better. So if we look at this, right? So the idea is, so now you started populating this. So do they match? Yes. So we can actually have two cases. One is whether it's a star, because that's a hard case. The other case is not a star. So if it is not a star, so the formula is more like, if you think about it, okay, if they are not a star, so I have to be like, because it is just a normal character, right? So whether these two normal character including the question mark, because that can match it to anything. So these two has to match, and that also means like previously, if I minus 1, you minus 1, your basically it's like I minus 1, j minus 1, that value also needs to be true. So this has to be true, and then you and me have to match. So basically in this case it's a and a, so that equals to true. So the formula is, okay, if the previous value is a true, like the diagonal value on the top left is true, and also these two characters equal to each other, or see, there's a bracket, or they equals to question mark. Essentially, it also means they equal to each other. We will populate this value to be true. And then we will continue. So if you are a star, that's the complicated part. So what we do is, essentially, any of your neighbor node other than the diagonal part is true, you're true. So if here I'm true, so here, what is the value of here, right? So because this is false, so there's no way you can think about this. It's like this will map this, because, sorry, let me see. So this should be true. So this should be true because this means A maps A, and then this can mean nothing. So this can be carried over to true. And then if we map this value, it's like this A. Well, anyways, as long as 1 is true, this will be true from this direction. So they can be matched. So it's true. So because the other way doesn't make any sense. And then this is B. So as I said, this has to be true, and then so that they can be mapped. So this will be false. And then we look at this one, right? So this one, so it's like A and C. So they are not the same. So they're just basically automatically false. And then this is, as long as your neighbor has a true, you will be true. This is false. That's just bad. This is a true. So let's see why this can be matched, because this is the A star, this is the AC. Star can be a C, so this is a true. So this is a false because B not equal to C. Similarly, this A not equal to B, false. Star, okay, let's see. So this is false, okay, bad. This is a true, so that means this basically will be carried over to a true. But why this is true? So A star can mean A, C, B. Star can be C and B in this case. So this will be true. So this, okay, that's B and B, so you have to be true. And then they have to equal to each other, so that's a true. So basically, this is the value that finally what we want to return, which is true. So that just means if we code it up, it just looks like this, and then this will be the value. And then the time complexity is very straightforward. It's O m times n. So is the space complexity, because you allocate some arrays. So what I want to call out is actually I did look up, the values, and then this is this guy, like I believe lots of you should already know, like Tushar Roy. So he explained the DP solution pretty well, but he did not start with because this question in real interviews, unless you saw this, DP, normally what people do will do the recursion brute force, like what I did, and then trying to optimize, and then later maybe interviewer would be like, hey, give you a hint, or you realized, oh, exponential is bad, so how can I optimize? So, but he just directly jumped into that, but it's definitely very good and worth watching. And this guy, Guan Yan, he explained like this thing in Chinese. It looks like playing games, 主角光环，即便表如斯的星号，yeah, just worth read. I think it's pretty fun. And this guy used coding garden, so he coded up this solution like this. If you haven't noticed, this is very, very short, even with the recursion part, right? So his whole idea is, if you match to a star, all you need to do is like you only match the last star. So essentially he bypassed all the previous stars, only matched the last one. And the reason is not that intuitive, to be honest, but this guy answered pretty good. So, but why? So for example, why this one can pass the OJ, right? Because this one, like he said, is, so if you think about recursion, his solution is only recursion in the last branch, like last level, because he only like whenever he sees stars, he won't recurse until this is the last one. And then the reason of that is, only if the last branch does not match, that just means the previous one won't match either. So you basically saves a lot of computational time. But it's not very intuitive, to be honest, and he didn't really explain it that well. But just a thought, there's another way to solve this. Cool. That's it. Just leave me any comments if you have any like thoughts, or remember the design questions. If you want me to explain some design questions, I'm happy to look at the comments. Cool. Until then, see you guys next time.